Hello everyone. In this lecture, we will study about left recursion. Now, this term is very related when you will do parsing. So, let's understand left recursion. So, what is left recursion basically? If a CFG is left recursive, it includes a non-terminal such that so you have a variable, right? What are variables? All the symbols which are represented in capital letter, that is capital A to Z, any symbol between that. So I'm taking here A, capital A. If we are recursively generating productions out of it in such a way that whatever variable which is used on the left hand side is also used on the left side of the right production, right? So this the same variable which is used on the left side is also on the left of this production. So we can eliminate left recursion in three steps. First of all, we have to eliminate the null production, then we have to eliminate the unit production, and then eliminate the left recursion, right? So top down parsing methods cannot handle left recursive grammar. That is the reason why we have a procedure to remove left recursion from the given grammar. Now let's understand how to do that. If a CFG is represented in this way, where the symbol that was present, that is a variable which was present on the left hand side, and if you see on the right hand side, it is producing some productions. These are the two productions. Out of these two production, this production is also starting with the same variable that was present on the left hand side. So this is called as left recursion, and beta does not begin with A. So this beta is not a part of your left recursion. So left recursion is only available in this production, and we need to resolve it. So here you can see this is a given grammar which is without left recursion, that is without non-left, or it is also called as non-left recursive grammar because it is not having left recursion. Is if you are given any production, you will first of all try to identify uh, these three components, alpha, beta, and the variable, and then you will apply this rule that A will produce the production which is not having left recursion, that is beta, and you are going to introduce a new symbol. If it is starting with A, then you use A dash, or if it would have been S, you can use S dash. So we are taking another production which is not having left recursion, that is beta, and beta A dash. We are introducing a new symbol A dash. Now we will also write the production for A dash. A dash will now produce what was the symbol which was ahead of the left recursive symbol, that was alpha. So alpha A dash, and there will be one more production will be generated, that is epsilon. So in this way you have to write it, and when you will see some examples you will understand how to do this question. So this left recursion, this particular thing that we have done, is specifically used when we are referring top down parsing techniques, because top down parsing techniques cannot handle left recursion. So that is the reason we need to remove the left recursion. Now let's so you can see this is the given grammar. Earlier I was using the language, ye dekhiye, the production here is this one only. What I'm trying to do, every time I'm using this production, I can use it any number of times, but to end this we have to use beta. So here you can see I'm using A is producing A alpha, again A is producing A alpha. In this way I can use A alpha any number of times. I can keep on expanding this, but in case I have to stop it, I have to stop the height of this derivation tree, I'll simply put the terminal value. So I've replaced it with beta. Also, if you see the other example, if you see this other production, so A is producing beta A dash. You can see A is producing beta A dash. Now what A dash will produce? A dash will produce alpha A dash. So A dash has produced alpha A dash. Again at the place of A dash I am using alpha A dash, and at the place of this A dash I need to end it, so I can use this epsilon. So I've used epsilon here, and you can see both are alike only, but there is a different of they means they are represented in different manners. So if this is causing any issues, better is you can write a different structure for it, which will avoid the problem, and both will also generate the same string, and this is called as your right recursion also. Now if I see this example, you can say that this is left recursive grammar. Reason is, you see the symbol variable on the left side, that is capital. There are so many productions which are starting with capital A only. This one until M productions all are starting with this A, so these are having left recursion, right? And if I talk about beta 1, beta 2 till beta N, they are not having left recursion. So beta I begins with uh, capital A, where no beta I, it is saying none of the beta production is starting with A. So as I've already told you, you have to pick the production which is not having left recursion. So simply you'll write A will produce what? Beta 1, beta 2 till beta n. None of them is using left recursion. So we'll also add one new variable here. So either new variable can be A dash. So we can write beta 1 A dash, beta 2 A dash till beta n A dash. Now what A dash will generate? A dash will generate what was the symbol which was ahead of this left recursive symbol? That was alpha 1, alpha 2, alpha m. So alpha 1 A dash, alpha 2 A dash, and keeps on going. And in the end, it will generate what? Alpha m. And this alpha m will be also included with the A dash. I have forgotten to write this. It will also have A dash here. And in the end, what we will have? Epsilon. Okay. Now let's take some more example. This is very simple. You'll write A is producing what? Non-recursive, non-left recursive production. Beta A dash will produce alpha, and after alpha we'll have the same symbol A dash and epsilon. Then another production is this. This production is having left recursion. So I'll write A is equal to beta 1 A dash and beta 2 A dash because they are not having left recursion. And then A dash will be alpha A dash, and it will also produce one more production, that is epsilon. Then I can write this. You know that only this is having left recursion that I have highlighted here. So, and these productions are not having left recursion. So I can write beta 1 A will produce beta 1 A dash, beta 2 A dash till beta n A dash. And A dash will produce what? Alpha and A dash and then epsilon. And finally, some more example, last two examples. A is producing A alpha 1 and A alpha 2 and beta. These two productions which I have underlined are having left recursion. So what I'll write, I'll identify the production which is not having left recursion. So A will produce beta, and new symbol I have introduced A dash, and A dash will produce what? What was ahead of A? Alpha 1. Alpha 1 A dash, and then alpha 2 A dash, and a new production that is epsilon. And last question is this. Again, the underlined productions comes under left recursion, and beta is not having left recursion. So I'll use A will produce beta A dash, and A dash will produce alpha 1 A dash, alpha 2 A dash till alpha m A dash. And again, epsilon will also be added here, which I have forgotten to write. Okay. So these were some few examples of, you know, finding out left recursion, removing left recursion from the given grammar. So in the next lecture, we will understand about left factoring. Till then, stay tuned. Thank you so much.